Hello and greetings everyone, I'm Nenad Petrovic and I will present the paper that we wrote together with my colleague Issam Al-Azzoni. And the paper is entitled, as you can see, do you see my screen now? Okay. The paper is entitled Model-Driven Smart Contract Generation Leveraging ChatGPT. I'm Nenad Petrovic and I'm coming from University of Niš, Faculty of Electronic Engineering, Department of Computer Science in Niš, Serbia. And I will present you the paper that we wrote together with my colleague Issam Al-Azzoni from Al-Ain University in United Arab Emirates. So we all know already that blockchains related technologies so far have been successfully adopted in many various domains, aiming like different case studies ranging from not only financial transactions as they were originally meant to be used, but also some other more sophisticated scenarios like transfer of intellectual properties, NFTs, and so on. However, as these applications have become more complex through time, the underlying scenarios also covered the usage of different information systems and other services, so the blockchain transactions became much more complex, and development of such contracts that would define the way that these underlying transactions will be performed has become increasingly difficult, especially in case of applications where we frequently have some updates of requirements on new features, such as, for example, unlocking new virtual content in metaverse, which is one scenario, and also like in-app purchases in mobile games. Therefore, significant effort is needed and time in order to add new smart contracts within the system, and also to cover the requirements that would satisfy the needs for novel scenarios or extend the existing ones. For that reason, tools which provide ability to generate smart contracts relying on automated or semi-automated means and money are actually something with what was demanded. On the other side, looking back on recent trends, since the end of the previous year, the so-called ChatGPT service, which is based on large language model, originally meant to be used as conversational agent, has been adopted in many areas, not only in programming and code generation, but also in essay writing, entertainment, and so on. However, our idea in this paper is actually to explore how this novel ChatGPT service can be leveraged for purpose of automated smart contract generation, with main aim to reduce actually both the effort and time which is required for development and their generation. In our case studies, we take into account Ethereum's blockchain and Solidity and DAML smart contract languages. As the outcome of this research, we propose a model-driven framework which treats the problem in a form as a dialogue in specific context between user on one side and on the other side ChatGPT service, which receives the prompts for generating corresponding smart contracts that would actually help on realizing some particular scenario. According to our results, the approach seems promising, especially if we consider the flexibility of such approach, where we have a very powerful language model able to generate target smart contracts for different technologies. When it comes to model-driven approach, we rely on other work, which is not under the scope of this paper directly, but is called IContractML. It's actually a modeling language which aims generation of smart contracts for 4 blockchain platforms. Actually, it has been already used for Ethereum, DAML, Hyperledger Composer, and in this particular work, we build upon this meta model, which was defined in the paper, which is actually introducing the IContractML 2.0, and according to results of that paper, which is other researchers' work, it was indicated that it's able to generalize well multiple smart contract languages. So this is the reason why we decided to reuse it in our work. As you can see, it has the main concepts as element relationship, smart contract, which is a resource, and parameters of a smart contract, which all make some transaction. And on the other side, we have participants which are involved into these transactions and their different roles of these participants. So we adopt this model, and here is a small example of iContract based scenario for very small system of for school grading and reward system, where we have three participants. First one is student, then we have teacher and parents. In this scenario, parents create a smart contract which defines reward to their children if they achieve some grades. The student can withdraw the amount which is transferred to the smart contract if a particular grade is achieved, or some target grade. The teacher can set the grade achieved by the student. So we have three participants, like we have teacher which can set grade, we have student which can withdraw amount, and parent who can like put some amount of like financial assets on the smart contract. Like we have single resource asset, which is a smart contract with two parameters. The first one is grade, the second one is amount, and we have three transactions, as I said, are associated to each of these participants, as mentioned before. So we have in this paper two case studies that will actually show later. The first one is based on this example, and the second one is a car bidding auction. So here is actually the outcome of code generation, which was achieved for Ethereum on left side and on the right side for DAMO smart contract using the proposed tool. Now let's go closer to what we propose in this paper. So actually what we had here is a related work, the IContractML and its code generation. We reuse the meta model, but for code generation we use ChatGPT. As this tool has its own code generator, but we go step forward, and actually now we'll say some words about ChatGPT. So it's as already known by most of the audience, like it's a novel AI-driven chatbot tool which enables human-like conversations. Users provide question on one side and additional information in form of a context, while the answer is generated by the service itself. It was publicly released like around the end of the last year by OpenAI, and it has drawn large public attention due to high versatility when it comes to various domains and tasks, from essay writing to programming, code generation and analysis. It's based on large language models which are trained on almost World Wide Web textual data archive up to 2021, and the dataset is being extended in novel versions. It leverages customized transfer learning alike methods for combining both supervised and reinforcement learning methods. There are two modes of usage. Free using graphical user interface, and programmatical using Python library, which is charged, and the charge is based on per token basis, which is actually calculated on the length of both the prompt that we send to ChatGPT and the generated response. So we tried both of them in this work. We rely on programmatic API basically in Python. We form the prompt using model-driven approach. Actually, this meta model is used in order to construct the corresponding prompt, and we transfer this prompt to ChatGPT, while ChatGPT returns the generated smart contracts. It has been already used in area of blockchain, and here are some related works. Aspects of security and vulnerability checks within smart contracts have been already analyzed in one of the existing words. Also smart contract generation for NFT based smart contracts, and also solidity smart correction was considered in existing literature. However, in this paper we have the following workflow. The whole solution that we propose here is available on GitHub, open source, on this link. In the first step, user creates a model according to IContractML 2.0 meta model and defines the parameters of smart contracts such as participants, roles, and parameters which will be used later for prompt construction. For this part, we rely on Eclipse modeling framework and we pass the created model. User uses a graphical interface generated directly from EMF, and here the parameters are specified. Furthermore, we pass the model, which is created by user, and perform the so-called model-to-text transformation, which actually constructs the prompt that consists of question and context pair and is forwarded to GPT. This is the algorithm, the underlying algorithm which constructs prompt based on provided IContractML 2.0 based model. So the input is a model created by user and the output is prompt. We get all the elements from the model. We distinguish between participants, asset, transactions, and parameters. For each of the elements, if it's participant, we add a new participant to the list and add that to the textual prompt that will be like there are the number of participants and we mention the participants are, and then we list from the model the past titles, the names of the participants. Moreover, we also define which are extract the assets and append them to the list, and also the parameters of a smart contract. And also here are the participants roles. We extract actually which participant is able to perform each of these transactions. So the prompt says participant, then name of the participant can execute the name of transaction. And in the end, we append to the prompt the desired target language. For example, we can say like write scenario in Solidity version 0.6. After that, once we have the constructed prompt, it is forwarded to Python script, which is responsible for sending this request as API call to ChatGPT online service. We provide API token that is generated on OpenAI website, and question and context are here put as input to API call. As output of this call to ChatGPT, we get the smart contract as output, which is actually the final code that we get as outcome. So we have two experiments. The first one is grading reward system with 3 participants, as I already mentioned, parents, teachers, and student. We have 2 parameters. The parameters are grade and amount. There are 3 transactions. As I said, create contract, set grade, and take amount from the account. Participant parent can execute transaction, create contract for rewarding the students. Participant teacher can execute set grade, like grading the student. And student can withdraw amount of money. And this is actually the whole prompt, as you can see in this row of the column. On the other side, we have another case study with 2 participants, and it's a vehicle auction. We have 2 rows, owner and bidder, 2 parameters, name and bid amount. There are 2 transactions, like change owner of car and place bid for the car. Participant owner can execute transaction change owner, and participant bidder can execute transaction place bid. And both of these scenarios are actually being done in both DAML and Solidity smart contract languages. And here are actually the outcomes of the experiments. When it comes to prompt generation, using the IContractML 2.0 tool, it was much faster. As you can see, it is of order of magnitude of around 20 milliseconds. When it comes on the other side to ChatGPT, it's order of magnitude of 10 seconds. So it's in this case actually 26 seconds in this particular example. And when it comes to prompt generation, it's much faster, but the code generation itself in IContractML is like several orders of magnitude more efficient, but on the other side we can see some additional added value on the part of ChatGPT. We have more complete code compared to IContractML. It can be compiled and deployed immediately. There were no syntax errors. The code was actually having some additional like checks, like some constraints that were not explicitly mentioned, but we can find them quite useful to make the system more, like to say, error prone. On the other side, when it comes to vehicle auction, prompt generation, as you can see, is also faster part of the pipeline, while the code generation using ChatGPT is like around 21 second, a bit less than 21 second. And here is also IContractML much faster. But we can see that again we have more complete code compared to the original contract generated by IContractML. We have like some additional code related to like auction end date, like constraint checks such as the bid amount should be greater than the highest bid in order to be valid, the array of bidders, amongst other things, which are also added by ChatGPT. So we can see that despite that we have like larger amount of time spent using to actually generate smart contract this way using ChatGPT, some logic is added which is not in the original model, but is most likely the code which is in right context and can be useful for developer and potentially lead to the overall added value to the system. It's ready for compilation and deployment in all the cases, which was not the case in iContractML, which generates a contemplate that needs to be filled in some fields by the developer. So, to sum up, in this paper, we proposed approach to automated model-driven smart contract generation relying on ChatGPT. It was evaluated in 2 case studies for both Solidity and DAML languages for smart contracts, and ChatGPT is much more flexible as we can quickly switch to another target blockchain technology we have without writing new algorithms as it's already trained on enormous amount of textual data. Also, it's adding additional pieces of code which can be quite useful, like checking constraints and some logic, preventing some improper usages and scenarios. And traditional code generation, on the other side, requires significant efforts to modify algorithms if we want to extend the notation of or use other blockchain technology, while ChatGPT is much more versatile and flexible for changing even in runtime if we want to achieve this. The approach seems promising, and in our future works we'll consider a code analysis when it comes like vulnerability check of smart contracts for different technologies, relying on ChatGPT, which I already explored in one of my other works in area of DevSecOps, like checking the constraints of deployment models for different technologies like Kubernetes, Terraform, Ansible playbooks, and so on. Thank you for your attention.